When we look up at night, we see one moon, a solitary, dead sphere of rock locked in a quiet orbit. But travel out to the gas giants, and that peaceful image shatters. This diagram lays out the scale of satellite populations in our solar system. While Earth has just one, Jupiter commands an entourage of 95 known moons, and Saturn recently eclipsed that, boasting 274 known satellites following the discovery of over 100 new bodies. With hundreds of bodies crammed into these orbits, it is easy to picture a junkyard of frozen debris. In reality, these hundreds of bodies function as the high-energy components of miniature solar systems. The host planets radiate immense gravitational and magnetic forces. These invisible fields constantly whip through the orbital lanes, warping, melting, and sometimes completely pulverizing the moons caught in their grip. Proximity to a gas giant overhauls the physics of a moon. It stops being a quiet rock, becoming a living, breathing part of a massive planetary machine. Take Jupiter's moon Ganymede. It is a behemoth. Wider in diameter than the planet Mercury, it conceals an ocean of liquid water roughly 100 kilometers deep beneath its icy crust. Beyond its scale, Ganymede possesses an anomaly found nowhere else in the solar system, a self-generated magnetic field. Looking at this cross-section of Ganymede, we can see the mechanism driving this field. Because the moon is locked in an elliptical orbit, Jupiter's massive gravity pulls on it unevenly. The planet stretches and squishes the moon as it moves, generating massive internal friction known as tidal heating. Down in the deep metallic core, that friction keeps the iron molten. Currents of liquid metal circulate, and depending on the sulfur content, particles of iron condense and fall through the liquid like snow. That convection creates a continuous electrical current, a magnetic dynamo. This internal engine produces spectacular ribbons of glowing aurorae at Ganymede's poles, but they do not sit still. Jupiter's own magnetic field is 20,000 times stronger than Earth's, and as the two magnetospheres clash, Ganymede's aurorae get violently rocked back and forth in the sky. A planet's gravity reaches across millions of miles of empty space to literally restart the geological heart of an ice world, preventing it from ever completely freezing over. Move over to Saturn's middle-distance orbits, and the rules change. Here, the moons are too small to have enough internal gravity to pull themselves into perfect spheres. Instead, you get bodies like Methone. This diagram maps out Methone's shape, a triaxial ellipsoid, or essentially a giant egg. It is the physical result of an endless orbital tug-of-war. Saturn's immense gravity pulls the moon inward in one direction, while the centrifugal force of Methone's own rotation throws it outward in the other. To maintain that smooth egg shape, Methone is composed of mobile, icy fluff. This loose, low-density regolith flows easily across the surface, filling in meteor impacts and erasing craters as fast as they form. It also has a distinct two-toned coloration. The leading edge of the moon, the side facing forward in its orbit, is dark, having been scorched by high-energy electrons trapped inside Saturn's sprawling magnetosphere. Methone does not dictate its own geology. For these middle-class satellites, physical shape and surface chemistry are commanded by the competing external forces of their host. They are prisoners of their orbital environment. In the innermost orbital zones, the gravitational environment is violent enough to actively consume the moons trapped there. Take Jupiter's tiny moons, Metis and Adrastea. They orbit inside the Roche limit, the boundary where a planet's tidal forces begin to overwhelm a satellite's internal structure. They circle the planet faster than Jupiter itself spins. Every time a stray meteoroid impacts their fragile, low-gravity surfaces, it blasts a plume of fine dust straight out into space. That escaping debris directly feeds and sustains Jupiter's faint ring system. Hidden within the dense fields of ice and dust are solid, long-lived bodies like the tiny 300-meter S2009 S1. For years, this moonlet was invisible. It was only during a planetary equinox, when the sun hit the ring's edge-on, that the Cassini spacecraft captured this rock, casting a sharp, 36-kilometer-long shadow across the icy debris. It proves that planetary rings are not permanent architectural fixtures. They are the pulverized remains of moons trapped in a gravitational death spiral. When you pull back and look at these giant systems from top to bottom, the isolated rocks disappear. What emerges is a single, grinding, interconnected machine. Inner moons are pulverized to feed the rings. Middle orbits host fluffy, egg-shaped bodies trapped in a delicate gravitational balance. And on the outer edges, massive ice worlds are squeezed so hard they generate their own planetary magnetic shields. These processes are happening in real time. Dynamos are pumping, rings are being fed, and surfaces are being scorched at this very second. Jupiter and Saturn operate as the planetary physics laboratories of the outer solar system. They prove that when gravity and magnetism operate on this scale, they dictate the physical evolution of everything caught in their orbit.